Hello, community. Now, if you're interested in an actual professional code version, how to fine tune a flying T5 model or T5 models in general, there's a beautiful link here on GitHub Huggingface Transformer, where they have here an example in PyTorch about the summarization task for a fine tuning of a sequence to sequence model in general. Now, let me show you how a nice method is. You can have your git clone command. So I go here. Yeah, maybe clear my output a little bit so that you can see what's happening. So this is more or less it. This is the complete code that we need. Everything is done and ready. So first thing, we git clone here our Hugging Face transformer. Let's do this. And then we have, of course, to install some transformer dataset, some evaluation metric, like Rouge, for example. You know this, so we just install this here with a simple command. And then we find out that here the transformer itself, the standard transformer library on Hugging Face, is not up to date enough, because if you want, there is a nightly version here. So the leading and bleeding edge of transformer. So we have to install here from source that we have here a transformer version 27. So we go with the latest developer version because this is brand new. So beautiful. So we say pip install from source our Hugging Face transformers. And then we should have the latest version up and running. Let's see. It should be 27, 427 dev 0, and you can see uninstalling 26 is the default standard package, and we have now installed the latest version. So I record this on March 1st. So whenever you see this video, you will have, I hope, already everything included, that you do not have to execute this code for the latest version. Everything should be included in the normal transformer stuff. And you just normally do your transformer install. So beautiful. So this here is the nice thing. So we have here our transformer, some example in PyTorch for a summarization task, the fine-tuning of a sequence-to-sequence model. This Python file is called run summarization. And if we now look here in our data, we see here we have a nice directory here in Colab, transformer, Docker examples, notebook, and as you can see, transformer examples, PyTorch, and then we go for summarization. Here we are. And then, oops, we go for run summarization as you see here. Let's have a look at this here on the other side. So this is the Python file we're going to execute. And this is a file directly from the creator of T5. This is beautiful. So we fine tune here the library models from Hugging Face for sequence to sequence. Now it is a little bit different, and I did not take the time to convert it in our typical Jupyter notebook. So you have here a Python file. It's much easier to run. And as you can see here already, it checks for the minimum version must be 427. A developer version, it checks for the minimum requirement for the data sets, and it tells you a lot of different things. Now, if you scroll through, you see that they have quite a lot of classes and a lot of models taken care of. And this is the beautiful thing here, if you have here professionals doing this. This file was for me last updated yesterday. So I don't know when you see it or the version you see when you here do your git clone command. But this is my current version. And as you see, I'm looking here for the summarization task. And there are quite a lot of data set that they already prepared this. And we can now choose if we want here. What I showed you, wait a minute, was the xsum We did this, I think, 2 videos ago, and my last video should have been about SAM-SUM. So these are the 2 data sets that you know. So either we go for XSUM again, that you see it, or we go for, yes, SAM-SUM sounds nice. Maybe we take this one or whatever they prepared for us. You see here, XSUM here is the default that I put in here. Maybe let's try a smaller one with SAM-SUM. Beautiful. So just my directory name gets another name, SAM-SUM. So this is the Python file we're gonna execute. And I would say, let's go for it. Now the beauty now here in this kind of doing this, that this is all we need. Everything has been taken care of. Now let's have a look what's happening here under the hood if you want. Please install pip install. Oh gee, did I forgot to activate some of my, sorry, my mistake. Yes, I'm not utilizing my GPU. I know. Sorry. Oh, here we go. Yeah. Oh, where am I? Transformer. Yes. Pro version. Go. So, whenever I change something that I already prepared, no wonder then suddenly we need another library in addition. So, let's have a look at this. What's going on here? Everything is coming down. Yes, yes, yes. So, let's start at the very beginning. What is the system telling us? Okay, so we have here sequence to sequence. Beautiful. We have GPU 1. That's great. Then we have our Atom. Beautiful. Then we have here our data loader. You have here deep speed is none. This is correct. This is for the next video. Evaluation, as you see here, I have floating point 16. So we go with half precision, because I want to go with a Google Flan T5 base model. What else? I will not put this on the Hugging Face hub. I will, learning rate, beautiful, local rank, the logging, scheduler, this is nice, metric for best model, none, okay. Push to hub is false, everything. Torch compile, warm up steps, decay, okay, you can optimize here quite a lot of. But never mind, everything is downloaded. And then you can see here, our architecture is T5 for conditional generation. This is what we are looking at. And then you see here the different task-specific prefixes that we have. So I showed you we have the prefix summarize, where you can have the prefix translate English to German for this particular downstream task, English to French, English to Romanian, yes, beautiful. Then we are downloading, yes, okay. Where are we? Configuration, running tokenizer, oh, we're tokenizer. Yes, we have here our NVIDIA CUDA cores half precision, this is it. And I would say we are already running. We are already fine-tuning our model. As you can see here, it takes about half an hour, 37 minutes, 46 minutes. And we are already 4% in. So you see, this is a way, if you are familiar with fine-tuning and you know exactly what's happening under the hood, that you can use this way. I think it's a little bit more professional. Remember, this was just updated yesterday by the professionals working in this area. So I think you're good to go if you also use their files and their way of fine-tuning here sequence to sequence models in general, transformer models. You can see here we save here our configuration. I have checkpoints every 500. Tokenizer is saved. Special tokens are saved. Takes another 36 minutes to finish, but bene. So let's stop this. Let's have an interrupt. Let's see with our resources. You see 12.7 gigabyte from 15 gigabyte GPU RAM. So it works really nice. And we have, as I told you, we have a flan T5 base here. Now you might ask, okay, but last time, in my last video, I showed you we used here from Philipp Schmidt here a particular way to fine-tune a flan T5 base model on the Samsung dataset for dialogue summarization. And this model is saved. We did it last time. And now we take this model as a starting point and we run the same summarization again. So we further fine-tune the model. And now we use here a new data set. This is from CNN, the Daily Mail data set. We have here again the summarization task that we're interested in. And training batch size 4, we go a little bit down, batch evaluation batch size 4, and we also run with half precision. So I would say, let's have a look here. GPU RAM is down again. So let's go with this one. Let's see. Yes, this compiler. No, we're not operating on XLA. Yes, yes, yes. Okay, everything is downloading. Everything is happening under the hood. Beautiful. So generating train split. As you can see here, we have close to 300,000 different data sets. So now it is creating our training data set. Takes about 1 minute. Okay. RAM is fine. So I suppose we just have to wait for this to finish. Yeah. Clear output. Clear output. I think we also have a T4. Well, I think more or less everybody has a T4 nowadays, if you have your free Google Colab notebook, but let's validate afterwards. As you can see, we are downloading now our PyTorch model. We are operating 427 as it should be. Running tokenize on the training datasets. So here we go. So this takes about 11 to 12 minutes to finish this here, as you can see, because our training dataset is quite mighty. 287,000. So this will take quarter of an hour and I will be back with you in a second. So, and we are back. You can see here, we are now running here our fine tuning. We have half precision on our backend. And what is the time? We are 35 seconds into it, and it tells us it needs another 46 hours. So you see 44 hours, 45 hours. So we are not going to wait for this. I just wanted to show you GPU RAM on 13 gigabyte, quite stable here, all in the red, yeah, but it's working fine. And if you would have the time, 45 hours to wait, you would, my goodness, where are we? Just scroll back. What are we doing? We took here our already fine-tuned flan T5 base model, fine-tuned it with the code from Philipp Schmidt on the SAM dataset for dialogue summarization. And now we fine-tuned it further. We took here a data set from CNN, Daily Mail, quite a huge data set. And as you can see here, even with the base model running on just one GPU, we managed that it takes close to 45 hours. So 46 hours, 47 hours, 46 hours. So beautiful. Now let me stop it here because we are not going to wait till it is finished. And this summarizes a methodology how you can do with git clone. But of course, you might ask, if I have more than a Tesla T4, how will I do it with Accelerate?